Hi guys, we're going to go on to lesson 3 of our grade 7 integers unit. As a quick review, as a reminder, integers are positive or negative numbers or positive or negative amounts of something. Thinking about positive means you're increasing something, something is going up, you're going forward. When we're talking about negative integers, negative amounts, you're decreasing, you're withdrawing something, it's going below, it's lowering itself, okay? And a quick reminder of understanding the greater, less than and greater, oh, well, I have two less than signs here. Less than or greater than sign when we're talking about integers. The larger the number it is into the negative, the smaller it actually is. So negative 12 is less than or smaller than negative 3. Okay? 2 is greater than negative 14. Okay? One way to think about it is where those numbers would be found on a number line. Okay? The further to the left they would be found on the number line, the smaller they are. Or if you are using a vertical number line, the further down a number will be found, an integer will be found on the number line, the smaller it is. Okay? All right, so we're going to go on to, in our Math Makes Sense practice booklet, lesson 9.3, representing integers on page 185. And it has a quick little review for us. You can use tiles to represent integers. Yeah, tiles are a really good way to visualize and manipulate integers if you're having trouble understanding them. So positive and negative. When you group a positive and a negative together, it is equal to 0. So this is what we call a zero pair. It's like you had a cookie, there's your positive integer, and then you ate it. So now there's no cookie left, okay? You had $1, you spent it. There's nothing left, okay? Those are called zero pairs. They neutralize themselves out, okay? So it gives us some examples. Here are 3 ways to model negative 3. So you can show it with 3 negative tiles. Negative 1, negative 2, negative 3. Or you can do it with a variety of tiles, a negative, a positive and a negative, which makes a zero pair. That means that this is gone. Another negative. Here is another zero pair, so this equals 0. And a final negative. So once again, what we're left with is exactly like the first example with 3 negative integers shown. And then again, they have it like this, where they've organized them into their zero pairs at the beginning, and at the end, they have what's left over. I like this strategy. It makes sure, it ensures that you are not making any mistakes, or you're not, because you have, say you've taken your I like the red is negative and the yellow is positive. So let's do that. If you are doing that with positive and negatives, it ensures that you do not mix up how many integers you have left. You don't put something off to the side and make it and miscount. When you organize them nice and neatly at the beginning, you quickly see your zero pairs. You can get rid of them even, get them out of there, and then you have what's left. Okay? Just a little strategy I like. Helps my brain stay a lot more organized. So yeah, they organize their zero pairs at the very beginning. They understand that these represent nothing. Nothing is left there. So all you have left is the 3 negatives at the end. Okay? So write the integers modeled by these tiles. So here they have the tiles. If we look at the tiles, we have a positive, 1, 2, 3, 4, 5 positives and 2 negatives. Okay? Arrange the tiles into rows. So they take these tiles and they put all the positives on the bottom, all the negatives on the top. Then, so they take these positives, put them onto the bottom, and then they take these negatives, and when they start making their zero pairs. Now we can see the zero pairs. These are done. And what do we have left? Positive 1, 2, 3. So that is positive 3. So if you think about using the tiles, and now if you think about how can we show that with numerically with integers, we look at what we had to begin with. We had 5 positives, and we added 2 negatives, negative 2, and that left us over with, that's the same thing as, I like to say the same as, for the equal sign, I think it helps people understand it better, is the same as. Positive 5 plus negative 2 is the same as positive 3. Just like with adding from when you were very little and you learned, 2 plus 3 is 5, so then 3 plus 2 is also 5. The same thing applies with adding with integers. We could say negative 2 plus positive 5 is equal to positive 3. And we can show that with the tiles. If you need to, the same thing happens where you can show that with your number line. If that's the way your brain is working, you don't like to use the tiles, you like to use the number line, do it. Okay? Same thing with this. If we show it with a number line, I'm going to go up and down just for space sake here. If we start off at positive 5, 1, 2, 3, 4, 5, here's positive 5, and we're going to add in 2 negatives. Negative means you go down. So we go 1, 2, and it gets us here to positive 3. Oh, that's very hard to read. Positive 3. Okay? Same thing, I can show you that here using if we were writing out the equation in this way. Here's our 0 point. We have to start off in the negatives on this one though. So we're going down below. Negative 2. But then it says we're going to add 5 positives. Oh, we're adding 5 going up the number line. So we're here at negative 2. 1, 2, 3, 4, 5. So if this is 0, this is positive 1, positive 2, positive 3. And once again, we get the same answer. Okay? Different ways you can do this. You can use your tiles. You can use number lines, either vertically or horizontally, whatever works for you. And once it makes sense in your brain, start using just the negative and positive integers. Okay, so a little bit of practice. Okay? Write the integer modeled by each set of tiles. So if we look at this one only has positives in it. How many positives? 1, 2, 3, 4. So this is positive 4. Okay, you can do B, it's with negatives. C, let's take a look at. Here is when we group things together and we end up getting our 0 pairs. So this is a 0 pair. Some people circle them, I cross them out. Just what I do. Cross them out. What do we have left? Only 1 positive. Positive 1. You can do the same thing for the rest. That's on you. Number 2, draw tiles to model each integer. Okay, you can draw them either using 0 pairs in there, or you can draw them just representing the amount of tiles. So for example, positive 2, you can just do this. Positive 1, positive 2. Okay? If we go here, negative 3, negative 1, -2, -3. That's fine. Okay? 3, use tiles representing +1 and tiles representing -1. So that's what each tile represents, is a +1 and a -1. Okay? Draw tiles to model +2 two more ways. So they give you this example. Here's a way to show +2. These are 0 pairs. They are neutralized. So what do we have left here? It's only +2. You need to show it to me in 2 other ways. Okay? So either you can make more 0 pairs, fewer 0 pairs, however, whatever you want to do, just ensure that your picture demonstrates +2. And number 4, explain why you cannot model +2 using 3 tiles. Why is it impossible to demonstrate +2 using 3 tiles? That's on you. All right, guys, that's it for lesson 9.3. Next lesson we will be going over will be adding integers with tiles. So we're going to be taking those tiles and adding them together. All right, guys, take care. Make sure you get all your work done. See you next time.